Okay, last time we completed the square for perfect square trinomials, and we're going to use that technique to solve quadratic equations. So for this one here, we've got x squared plus 8x, and then on the other side of the equal sign, we have equals 65. And so what we're going to do, we're going to complete this square. So that means we have to take this number here, cut it in half, and then square it. So that would allow us to complete the square here on the left hand side. So half of 8 is 4. If we square that, we get 16. So we do x squared plus 8x plus 16. So that's going to complete the square on this side and create a perfect square trinomial here. And then, since we added 16 to the left-hand side of this equation, we have to also add 16 to the right-hand side. So just because we got to keep our equation in balance. So equals 65 plus 16. Okay, so x squared plus 8x plus 16. Again, remember that would be factors of 16 that add up to 8. That's going to be 4 and 4. And so this will factor into x plus 4 times x plus 4, or x plus 4, squared. Okay, and then that will equal, and 65 plus 16 is 81. So now what we have is we have a perfect square on this side, and we have a number over here, which happens to be a perfect square as well. So if we wanted to, so what we'll do is we will take the square root of this side and take the square root of this side, and then we'll be able to solve this equation. So we'll take the square root over here and take the square root over here, and we're looking for all possible solutions on this one. So this will be x plus 4, because when you take the square root of a square, you get whatever you were squaring. So then I have positive or negative 9 here. So I can break this up into two equations. X plus 4 equals positive 9, or x plus 4 equals negative 9, just like that. Subtract 4 from both sides, I get x equals 5, and then subtract 4 from here, both sides here, I get x equals negative 13. So there's our two solutions to this equation. Now the cool thing about solving quadratic equations by completing the square, which is doing the process we just did, it works for any quadratic equation. So like factoring, you can only do that with quadratic equations that are factorable. Square roots only works for specific forms of quadratic equations. This one will work for any of them, and it'll give you both the real solutions, and if there's any imaginary solutions, it will give you those as well. So we'll do another example here. Okay, so here's a new equation. We want to solve this quadratic equation, so we're going to solve it by completing the square. So what we'll do is we're going to cut this in half, so that would be negative 1. Then we'll square it, which is 1. So we're going to add 1 to both sides. So we get y squared minus 2y plus 1 equals, and then remember we added 1 to the left-hand side of our equation, so we have to add 1 over here as well. So plus 1 like that. So now this is y squared minus 2y plus 1 equals 9. And now we'll write this as a square of a binomial. So remember, if you need to, it's factors of 1 that add up to negative 2. So that would give us y minus 1 times y minus 1, or y minus 1 squared equals 9. Take the square root of both sides. We're looking for both the positive and negative root. This will be y minus 1 equals positive or negative 3. So I'll add 1 to both sides, so we'll rewrite this as y minus 1 equals 3, or y minus 1 equals negative 3. So this is y equals 4, or y equals negative 2. And there's our two solutions for that equation. Okay, so we've got a new one here, x squared minus 14x equals negative 50. So we will complete the square on this quadratic here. So half of negative 14 is negative 7. Square that, I get 49. So we're going to add 49 to both sides. So we get x squared minus 14x plus 49 equals negative 50 plus 49. So this left side, factors of 49 that add up to negative 14, that would be negative 7 and negative 7. So this will be x minus 7 times x minus 7, or x minus 7 squared, and that'll equal negative 1. So what we'll do, take the square root of both sides. We're looking for both the positive and negative roots there. This will be x minus 7 equals, and then what we get over here is the square root of negative 1. And at this point in our career as mathematicians, we are not sure what to do with that. This actually creates an imaginary number, and for now, we're just going to say no real solution. So that's where we'll end something like that, where you're taking the square root of a negative on this side. So we'll leave it at that and move on to another. Okay, this will be our last one. We've got x squared plus 6x on this side, and we got 41 over here. So we're going to complete the square on the left. So take 6, cut it in half, that'll be 3, and then square it, that's 9. So it's x squared plus 6x plus 9 equals 41. And since we added 9 to this side, we have to add 9 to the right as well to keep our equation in balance. So now x squared plus 6x plus 9, that factors into x plus 3 squared equals, and then we'll get 50 over here. So we'll take the square root of both sides. We're looking for both positive and negative roots there. So this will be x plus 3 equals positive or negative square root of 50. And so what we'll do, we'll break this up into x plus 3 equals the square root of 50, or x plus 3 equals the negative square root of 50. And we'll subtract 3 from both sides here. This gives us x equals the square root of 50 minus 3. Make sure you make it abundantly clear that this minus 3 is not inside the radical. And then we've got x equals minus 3, like that. And we got to clean this up a little bit, so we'll move this here. The square root of 50, I'll do it up in the top right actually. So the prime factorization for 50 is 2 times 5 squared. And so this, the 5 squared is a perfect square, so we can take the square root of that, that would be 5, and then this is not a perfect square, so we'll just leave it inside the radical. So this is 5 times the square root of 2. So we'll get x equals negative 50, the square root of 50 minus 3, which is 5 root 2 minus 3. And I'm going to, well, we'll just write it like this, minus 3. Or, and then x equals negative 5 times the square root of 2 minus 3. And this is like, we can change this to an addition statement, so it's plus negative 3 plus negative 3. And then I'll get this one out front and this one out front and put our square root term at the end of it. So it's x equals negative 3 plus 5 times the square root of 2, or x equals negative 3 minus, or plus, negative 5 times the square root of 2, just like that. So there's our two solutions.